Hey everyone, this is Jeff Mankowski and I'm welcoming you back to the Maverick Statistics channel. In this video, we're going to go ahead and take a look at another example of the Chebychev Theorem. So we're going to go ahead and bring one straight up on the screen. And this example is actually, most of it was taken from an example Alan Blumen is using in his book, A Step-by-Step Approach to Statistics. And the example reads, a great white shark will stalk its prey for an average of 25 seconds before moving into attack. The standard deviation is 2 seconds. And Chebychev's theorem, using Chebychev's theorem, find the minimum percentage of stalking instances that will fall between 20 and 30 seconds. Okay, now before we even get into the mathematics or the computations, something that we're going to mention about keywords that's really important. Because when you're on your examination, your final or your first test, there are several different techniques that you're going to have to help you analyze what percentage of data is in an interval range. So if for some way your instructor or your teacher managed to write the exam in the question without using the phrase, using Chebychev's theorem, how do you know what formula to use? And the answer is, inside of here, we've got the keyword minimum percentage. And that's a really, really big help because remember, Chebychev is always going to use one of two catchphrases most of the time. Either it's going to speak of finding at least what percentage, or it's going to mention something about a minimum percentage. So that's where you know that you want to start thinking about the Chebychev theorem. Okay, now on the screen, we've got our three different pieces of the Chebychev theorem, and if you're not really sure where they came from, take a few minutes to look at the last couple videos that are posted on the Chebychev theorem where we introduce them. And when we're looking at the theorem, the formula components, one of the first things we might notice is that the exercise as it relates to the formula is kind of interesting because they didn't really mention if we're working with a sample or a population yet, did they? They're just kind of giving us the data, and the rest is up to us. Now, because it looks like it's to our discretion, we're going to go ahead and we're going to use symbols for sample average and sample standard deviation in our formula. That is X bar and S. If the information was geared towards a population, we would want to change those counterparts out for the symbols for a population. Now, in this case, it's not really going to make a difference in the final answer, though you want to make sure if it is actually specified in the exercise that you stay really consistent with your symbols so you can show you know exactly what you're doing and you're less likely to get into trouble. Okay, so which formula do we use first? Do we use second? Let's start over here and see what's happening with our proportion piece of the formula on the far left. It looks like to do some work in here, we would have to know either a value for K or a minimum percentage to set this equation equal to. Now, we know that K from the last videos is equal to the total number of standard deviations that we're going above the mean or below the mean to hit our 20 or our 30. Right now, we don't have any of that information available, so we can't really fill anything in for K. As far as the minimum percentage, well, the exercise is actually asking us to figure out the minimum percentage, so we can't do anything with that either. It looks like what we're going to have to do is use the formulas on the right side of the screen where we do see a K sitting there. Try to solve for K so that we can plug it back in over here and we can solve our proportion answer. So to get underway, let's take a look at what's on the right side, our X bars, our Ks, our S's. And it'll probably help if we draw a little separator line in between these two. And let's fill in whatever numbers we can fill in here. We know our X bar is equal to 25, so we're going to write in, working the left side, 25 minus, now again, we don't know a value for K, so we're just going to go ahead and leave it as it is, K. S, we don't really know, oh, well, actually, no, we do know S inside of the exercise. They've let us know that S is equal to 2. Okay, so on the right side of the equation, we're basically going to take exactly what we just wrote on the left, and we're going to make it the same thing but with a positive sign. So let's go ahead and fill in 25 plus k times 2. And it almost looks like we're stuck. What are we supposed to do now? We just still have k, but this equation, what do we set it equal to so we can solve for k? And the answer is up here. We're going to make the left side equal to 20. We're going to make the right side equal to 30. So we'll put in our equals 20 and our equals 30. And now we're in really good shape because it means that we have two different equations on the left side and one on the right side. So two equations, they both have one unknown and they're set equal to a number. So we can solve out for k. It won't matter which side you pick to solve, the left side or the right side, but personally, I like working with positives. So we're going to go to the right side. And let's go ahead. Let's first take what we have written straight up here. Let's clean it up a little bit. So we're going to say 25 plus 2k equals 30. And this is looking a little bit better. Notice that k is on the left side of the equal sign. So to solve this, we're going to make sure k stays on the left and anything that's not k goes to the right side. And the first thing that's sticking out at us, of course, is the 25. So how do we get rid of that? Well, the coefficient in front of 25 is a positive, so that means what we can do to get rid of the 25, we can subtract it from both sides of the equation. So we're going to come over here, we're going to say a minus 25 and a minus 25, and we're going to simplify now to 2k equals 5. And this is much more cleaned up, it's easier to work with. We have twice k equals 5, and obviously 2 has been multiplied against the k. We want to get rid of the 2, so it's just k. What undoes multiplication? The answer is division. So we're going to divide both sides by 2. We're going to have 2k divided by 2 equals 5 over 2. Both of our 2's will cancel here, and this is going to let us know that k is equal to 2.5. And this is really good. This means we're halfway home free. All we need to do is take this value for 2.5, and we're going to substitute it in on the bottom of the proportion. We'll be able to do our job and solve for that minimum percentage. So let's go ahead and let's work the proportion this time. We're going to fill in what we know. 1 minus 1 over our k is 2.5. We're going to make sure that we don't forget the square. Now, the right side of this is less than or equal to our minimum percentage. To make the math a little bit easier, just temporarily, we're going to take the inequality sign and switch it for an equal sign. And on the right, we'll leave in a question mark there. We don't really know what's on the other side yet. We'll get to that momentarily. And we're going to go ahead. We're going to simplify the function. We'll square the 2.5. So we're going to put in 1 minus 2.5 squared is 6.25 equals a question mark. And now we need to get 1 divided by 6.25. That's going to give us 1 minus 0.16. And this is going to equal 0.84. And we have to still watch because remember, we're dealing with inequalities. So what we're going to do is at the last minute, we're going to convey that we know there's a minimum percentage at work here. And the way we can do that is we can write in, let's take the 0.84. Mentally, we're going to switch that, configure it to a percentage. So we're going to say 84%. And then in front of it, this is important, at least. And let's circle this up to mark that we're completely done. And now that we know, at least 84% of our instances are going to be in between 20 and 30 seconds. So again, at least 84% of the time, the stalking instances are going to last between 20 seconds and 30 seconds. So now that we kind of have the answer, consider a follow-up question that if there was a shark and it's stalking its prey, and the stalking instance lasted for only, let's say, 15 seconds. could we decide, or would it be easy to say maybe that that shark was extremely hungry or hadn't eaten in days? And the answer is, knowing what we do from the Chebychev theorem, there's going to be a minimum of 84% of our instances that are going to be above that number we were just given. So we can tell that, yeah, that shark might have been extremely hungry. Maybe it hasn't eaten for a while, and that's what made it be so aggressive. So there's some really cool ways that we can take the Chebychev theorem, we can apply it to understand at an even higher level what's going on in the exercise. Now remember, our final takeaway, guys, is that when we're working with Chebychev, one thing that's kind of frustrating about it is we always have to refer to a minimum percentage, or at least this percentage of data. And the reason why that's happening, the reason why it's not too approximate, is because we don't really know anything about the data that we're working with. All we really know is an average and a standard deviation. So if we don't really know that much more about the data, we kind of have to be pretty vague. And that's why the Chebychev's theorem isn't really getting more approximate. It's always using at least a minimum percentage. The good news, though, is once we know more about the data, like we happen to know if the data is skewed or if it's bell-shaped, then we can start to get more sophisticated, because we're going to know which techniques apply given the behavior of the data set. In our next video, that's what we're going to talk about. We're going to get into, if we happen to know our information, our data came from, let's say, a population that was bell-shaped, what then could we roll out that would give us even more sophisticated estimation techniques? As for now, I hope this video was helpful, and I'll see you on the next. Thank you for watching the Maverick Statistics channel. This is Jeff Mankowski.